Hello everyone, I'm Meghamala, Working Assistant Professor from Institute of Aeronautical Engineering. And I welcome you all once again for the subject microelectronics. So here I am to talk about the subject microelectronics and few topics under the microelectronics subjects. So quickly let's move forward with the topic bipolar junction transistors. So before we go forward, let us know about what is a microelectronics. So basically here the name itself indicates that it colloquially refers to a microchip. It means that number of transistors which are placed on a same single chip, right? So for example, here I can say that the gist of microelectronics given as it is a subfield of electronics. That means what the prerequisite if we consider for this microelectronics subject, we can consider the basic EDC, that is electronic device circuits. So this electronic device circuit is a prerequisite for this microelectronics subject, whereas here in this microelectronics we are going to study about the transistor, different types of transistors, amplifiers, and also the switching designing and the mechanism of each and every microelectronics which is related with this digital devices or else the circuits, electronic devices circuits. So here the name suggests the microelectronics, it relates or else the study is all about the manufacturing and the development of micro devices, okay, micro devices, the small micro devices or else micro elements. Here you can see that it is always means that the micrometer scale or smaller. So this is a microelectronics. It means that it refers to a micrometer, the small tiny devices which are placed under a chip, right? So it is nothing but a smaller devices which indicates or else the micrometer scale. And then we say that these microelectronic devices are made by using semiconductor materials. So we all know that the semiconductor materials are nothing but the germanium and silicon. So why are we considering only these two basic materials like germanium and silicon? Because one thing we have to remember that in order to design some electronic devices or else in order to design some modules, some devices, we have to dope that elements, right? We have to dope with this particular. For example, germanium can be doped with the arsenic. Then we call this as a semiconductor material. So likewise, the semiconductor materials, especially germanium and silicon, we are considering because the energy gap for this is 0.5 and 0.7, 0.7 and 0.5. And also when these germanium and arsenic or else germanium and silicon, when these two elements, when they are doped with some 15 elements in the elementary table, if they are combined with the different elements like arsenic or we can say that phosphorus, then the combination of those two can be combined and called as a semiconductor materials. Okay, so in order to design or else in order to develop a particular electronic devices or as a transistor, we can say for example transistors, resistors and whatever it is which is comes under the electronic devices. Simple thing is they should be like we have to consider the semiconductor materials, and under the semiconductor materials only germanium and silicon can be considered first. The priority can be given to germanium and silicon first, and then so here this is a field of electronic engineering and that deals with the design and fabrication of small electronic devices. So overall we have to understand one thing when it comes to microelectronic is the designing or the development of the devices for the small devices, right? So the fabrication and designing of the small electronic devices such as microprocessors using the technique photolithography. So we know that what is meant by photolithography. It is nothing but the photoresist, the introduction of photo. Okay, the introduction of light therapy can be considered, whereas we calling it as photolithography. That means when you are designing some particular devices, for example, let's say microprocessors, some microprocessors if you are designing, or else if you are designing some chip, let's say some chip. So for this purpose, when you are designing, it should undergo some process. Okay, that process can be considered as a fabrication process. When the particular chip is undergoing some fabrication process, it has to undergo a few steps. Like etching is one of the step, that is, and also the photolithography is one of the step. And as finally we are going to finally, in order to obtain the particular proper outcome, it has to go through proper steps, certain steps. So one of the step is photolithography. Okay, photolithography, here you can see that there are 6 major steps that we can follow. The first one is in order to get a proper outcome, first thing is when you are fabricating some chip, the first and foremost thing that you have to consider is the substrate and the metal. And then after that metal, what we are doing is photoresist. Photoresist is nothing but the introduction of light. Right, so the introduction of light over the metal. So here in the third step, in the C, you can observe the light is introduced, where the photo mask is applied, or as a mask is meant over there, and to a certain area, till the certain area, the light can be introduced, and the rest of the area it can be omitted. So here only this particular area, the light where it was introduced, or else when it was observed, the metal when observed the light, what happens is it will consider only a certain part, and the rest of the part it can be etched out. And then we are seeing at E, we are seeing a proper substrate can be proper substrate is meant over there with respect to the silicon and germanium, using silicon and germanium. And then finally we are getting the metal and substrate in a proper design. So here onto this metal we can what we can do is, like, this metal, onto this metal we can properly the doping of semiconductor materials can be done, whereas this finally we can obtain a proper chip. So this is meant for the designing and the fabrication of a particular chip can be done over using photolithography is one of the steps. So here this is nothing but the photolithography. So not only the photolithography, it will undergo many things, but here we have highlighted using a technique called the photolithography. And also we can say that these devices are typically fabricated, or as they are designed using micro electromechanical systems. In short form we can call it as a MEMS. So these fabrication of particular devices can also be done using MEMS. So here this is micro electromechanical system. So we can say that it is a micro which is small, electro using the electronic devices, and mechanical, the performance of the mechanism what we are using over there, and then finally the systems. So these are small structures and that can be integrated onto electronic circuits. So if, for example, if this is a electronic circuit, over onto this we can place a number of small devices, a number of small numerous small devices can be placed over onto a electronic circuits, where we are calling it as a microelectronics, right? So we can say that typically we can also fabricate MEMS devices as well. Then coming to the first important topic of this microelectronic circuits is bipolar junction transistors. Already we have discussed, as we are the electronics students, we have discussed we are ever known about this name, bipolar junction transistors, right? In the electronic device and circuits is a very first and foremost important subject that we'll come across in the second semester. So bipolar junction transistor is also one of the important topic to be remember. It's like an introduction for this electronic devices, right? So this bipolar junction transistor, it is a three terminal device in which the operation depends on the interaction of both majority and minority carriers. So we all know the majority and minority carriers, they are holes and electronics. So the interaction between the holes and electronics is nothing but the operation of BJT is done with the interaction of electrons and as well as the holes. Then there are the famous people that we can see over here. These three people are the inventors of the first transistor. Okay, the first transistor was invented by these three famous people, and they are Brittain and Shockley in 1948. As it has got revolutionized in the electronic industries. So the electronic it was like these people, because of these three people, I can say that the electronic the devices that we are using in our day-to-day life have come into life because of this three person. And the bipolar junction transistor is so named. Why is so named? Because the name indicates it's a bipolar, right? So bipolar means the operation which involves here two kinds of charges, that is holes and electrons. As we have said that the majority and minority carrier interaction is done. The interaction between the minority and majority carriers is considered over the bipolar junction transistor. And here the wide applications in computers, satellites and other modern communication systems. So usually with the help of these transistors, I can say that the applications, the consideration of this particular bipolar junction transistors can considered in the fabrication or else in the designing of computers, in the designing of satellites and other communication devices as well. So here we see the diagram, the representation or the symbolic representations of bipolar junction transistor. So mainly the bipolar junction transistor we can construct with the two main concepts, that is PNP and NPN transistors. Okay, PNP and NPN transistors, and this is the bipolar junction transistor where we can see the three terminals 1, 2, 3. 1, 2, 3. 1, 2, 3 terminals are represented as emitter, base and collector. E represents emitter, B represent base and C represent collector. So here you can see the difference between PNP and NPN is nothing but the emitter junction. The introduction of emitter junction over here, you can see that for NPN transistor it says that the arrow mark, it goes towards the emitter, whereas here for PNP transistor we see that the arrow mark is going towards a base, like towards a base, right? So this is the difference between NPN and PNP transistor, that is BJT. And in the coming classes we'll in detail, in depth, we will know what is NPN transistor and what is PNP transistor with certain graphical representations as well. So now comes under the constructions of BJT and its symbols. So in the previous slide we have discussed like the symbols of PNP and NPN transistor. So here also we can see we have the emitter, base and collector junctions of both PNP and NPN transistor. Right, so the important thing you have to remember is for PNP transistor, you can see the arrow mark of emitter is going towards the base, and when you consider, the priority can be given to NPN transistor instead of PNP transistor. Okay, and then these three terminals are labeled as emitter E, base B and collector C. And the current which are flowing from these three terminals are given as collector IC, collector current IC, base current IB and the emitter current IE. And then there are two basic types of bipolar junction transistor construction, that is PNP and NPN, just now we have discussed, which basically describes the physical arrangements of P-type and N-type semiconductors, okay, from which they are made. So P-type semiconductor and N-type semiconductor. So first one I can say that is a P-type semiconductor and it is the N-type semiconductor. That means the interaction between the holes and electrons can be made, the interaction between electrons and holes are differs in with respect to NPN and PNP transistors. And coming to this slide, particular slide talks about the transistors. Transistors are three-terminal devices which made from different semiconductor materials. As I said you, basically two semiconductor materials will consider. One is silicon and germanium. When the why we are calling it as semiconductor materials is obviously this silicon and germanium, they have to dope with some other element. Then only we can fabricate, or else we can get a particular outcome, a proper outcome of a particular devices, so semiconductor devices. Okay, so different semiconductor materials that can act either an insulator or conductor by application of the small signal voltages. So however, we are saying that we can call this particular semiconductor devices as insulators. What is meant by insulators? We know that insulators, they resist the current flow, right? And also the conductors. What is a conductor? It conducts the electricity, right? So the semiconductor materials, they can act either insulator and as well as a conductor by the application of small signal voltage. So here in this small signal voltage is nothing but it is nothing but the ratio of current to the resistor. So by using this small signal voltages, we can either come to a conclusion that based on the semiconductor that we are considering, we can come to a conclusion that whether it is a insulator or else whether it is a conductor. And then the transistor's ability to change between these two states enable to have two basic functions, namely digital electronics and analog electronics. So what is this digital electronics? The transition between these two. What are these two? Either insulator or conductor. The ability to change the states from one state to another. We can either go with the digital electronics or else with the analog electronics. So digital electronics is nothing but the switching. Switching means changing of state from one to another state, right? So we can say it is a digital electronics, and whereas the analog electronics, analog electronics, we come across the amplifications, right? Different types of amplifications. CE amplification, CB amplification and CC amplification, that is common emitter, common base and common collector. Okay, these are the configurations we will study with respect to the bipolar junction transistor. So in order to go with this amplification system, or else in order to go with the switching system, okay, switching system, in this switching system, in the digital electronics, we'll study about different types of switching times. Like we know that the rise time, fall time, right? Rise time, fall time, and different types of switching characters can be observed in the digital electronics. So here in a particular switch in digital electronics, we also studied about how the diode acts as a switch, right? How the diode acts as a switch, and also how the transistor acts as a switch. So here, as we are pondering on the bipolar junction transistor, in the coming classes, we will study how the BJT, how the transistor acts as a switch. So we will study the transistor in terms of digital electronics, and also we can study the transistor in terms of analog electronics. Then the bipolar transistor, it has the ability to operate within the three different regions. So basically, the transistor, this particular bipolar junction transistor, it operates in three different regions. The basic regions are active, saturation and cutoff regions, right? So active, saturation and cutoff. So in order to tell more about which region it is active, in which region the transistor is active or else it is on, and in which region the transistor is off. Okay, it's based on the current. It's based on the current and the voltages. For example, if you want to know the transistor is remains active in particular junction. So for example, here this particular table, gives us huge knowledge about how the transistor is active, or else how the transistor is presently working in which region. So here we see that BJT, region of operation. So in active region, I can say that the emitter base junction, EB junction, is forward bias, and in CB junction it is reverse bias. That means what? I can say in the previous slides we have discussed about the symbolic representation, right? Symbolic representation of transistor. So this is a transistor, right? So this is a transistor where, so this is transistor. Here we can say that this is a emitter, base and collector, right? So here if you see that this is emitter base region, this is base collector region, and this is emitter collector region, right? So here if you see, we can when we can say that the transistor is working in active region, the emitter base junction, when this emitter base junction is forward bias, and then collector base junction is reverse bias. When this is in forward bias and when this is in reverse bias, we can say that this particular transistor is acting in a active region, right? Region. The operation of this transistor is active region. And then coming to cutoff region. So in the cutoff region, the forward bias, we don't see any forward bias change, forward bias region. Only we see the reverse bias, and that too emitter base junction. Emitter base junction is reverse bias, and then collector base junction is also reverse bias. So in this cutoff region, both are in reverse bias. And then coming to the saturation region, we say that the emitter base junction should be in the forward bias, and also the collector base junction should be in a it also should be in the forward bias. So when this both junctions are in forward bias, then we say that the particular BJT, it is like the operation of that particular BJT works under saturation region, and it is a very important table to remember. And then finally the last point here says that reverse active. So reverse active is nothing but when emitter base junction is in reverse bias, and then collector base junction is in a forward bias. So these are the variations. So based on this variation, we can able to know on which region the transistor is operating. So the important regions that we have to remember is active region, cutoff region and saturation region, and the last region is reverse active region. Whereas here in this reverse active, we see the the active region forward bias, whereas in the emitter base junction for this active reverse, we see it is in a reverse bias, right? So this is an important table to be remembered, where from this table we can say that the operation of transistors can be observed, or else the operation of transistors can be observed keenly in which region, right? So here this graph is a whole soul of the operation region, or else we can represent the transistor is in which region, or else the region indication of the saturation, cutoff and the active region. So the bipolar junction transistor, it has the ability to operate within 3 different regions. So we have discussed like active region, cutoff region and saturation region. So here in the active region, whereas in emitter base junction and base collector junction, right? So in the emitter base junction, we see that in active region it is acting as forward bias, and in base also it is acting as a forward bias, right? Reverse bias, it is reverse bias. And then in cutoff region, we see that the emitter base junction, it is acting in a reverse bias, and also it is acting in a reverse bias, whereas in saturation, forward bias and forward bias. And the the region is reverse active. In the reverse active region, we are saying that totally it's acting reverse. So the emitter base junction, it is in reverse bias, and the base collector junction also in the base collector junction is in the forward bias. So it is totally opposite. If it is a reverse, whereas here it acting in the forward. Okay, so what is this active region? Active region says that the transistor operates as an amplifier, that is IC is equals to beta IB. So what is this IC? IC is collector current. IC is collector current, whereas IB is base current, whereas beta is nothing but the current factor, right? Beta is nothing but the current factor. So active region. So this is a particular graph where this graph is all about the current IC, collector current versus VCE, IC versus VCE. So what is this VCE? VCE is a voltage across collector and the emitter. So VCE is a voltage across collector and the emitter, and IC is a collector current. So this graph is all about the collector current versus VCE. So here if you observe, this is a Q point. This particular point is nothing but the Q point. This is a quiescent point where we see that as the current, as IC increases, we see that it varies with respect to VCE, and this is nothing but the IB, the base current IB, right? Base current IB. So here, this region, this particular region is cutoff region. Why we are saying it is a cutoff region? Cutoff region says that the transistor is fully off, because the transistor is fully off, whereas IC is equals to 0. So when the transistor is in off mode, the current flowing in the collector becomes 0. Then that particular region is nothing but the cutoff region. And what is saturation region? Saturation region is the transistor is fully on. When the transistor is in on state, then the collector current IC becomes I. So IC is equals to I in the saturation, and IC is equals to 0 in the cutoff region. Okay, so this is nothing but the active region. This region is meant to be a active region. So what is this active region? Says active region is equals to IC into beta IB, right? So here in this particular region, such saturation region, we are saying that the total collector current is equals to current I, that is total current, the saturation current I, whereas in the cutoff region we are saying that the IC, the collector current is totally goes down, that is IC is equals to becomes 0, whereas here it becomes maximum, where it totally becomes reduced to 0. It is a minimum current flows in the cutoff region, and this particular region is nothing but the active region, where here the collector current IC is equals to beta IB. IC is equals to beta IB. This is an important point and the important slide to remember when it comes to the operation of bipolar junction transistor. So this is all about the bipolar junction transistor, the very first and foremost topic of the first unit of microelectronics. So far we have discussed about what is a microelectronics. Microelectronics is nothing but colloquially refers to a small chip. Okay, colloquially refers to a small chip where all the ingredients are placed on a single chip, right? And then we have discussed about very first important topic is bipolar junction transistor. It refers to it is an interaction between the what do we say, majority and minority carriers, that is holes and electronics. And also we have discussed about the operation of the region, the conduction of the transistor. In 3 regions it conducts: active, saturation and the cutoff. So here in this particular graph we have discussed how the current varies, or the current and the voltages varies with respect to the active region, saturation region and as well as the cutoff region. So here in the cutoff region we are saying that the collector current totally becomes 0. Okay, minimum current flows, that is becomes totally 0. The current vanishes in the cutoff region, whereas in the saturation region we say that the maximum current flows. So the current at the collector is nothing but IC is equals to I, the maximum current flows, and in the active region we are saying that the current IC, the collector current IC is nothing but beta into IB, the total current which is flowing with respect to the base current as well. Right, so this is about the bipolar junction transistor. In the future days, we will discuss more about bipolar junction transistors and also the different topics which are in microelectronics. So this is all about today. I hope you understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.